Hi, this is our final design video presentation. We're Team 7. My name is Kevin Minghao Chen. We have Felipe Farraco and Matthew Zola. First, I'll go over the table of content for this presentation. We're going to go over the process flow diagram, and then we're going to move on to mass balance equations, the roast profile that we used, the energy used during roasting and brewing, the brew method, the coffee selection, and then the final sensory evaluation. Okay, first I want to break down this process flow diagram. As you can follow, the first process is to roast the beans. So we have the mass going in and mass going out for every process on the process flow diagram here. During the roaster, you can see the input are the green beans, and the output we have roasted beans, gas, and then the chaff. Then we take the roasted beans, we put it into the grinder, we set the grinder setting, and then outcome is the coffee grounds. After the beans go through the grinder, it's gonna go into a coffee basket. The water is going to get heat up in the kettle, and then the brewing will occur, and then we will have the final cup of coffee. Okay, to break out each balance equation for each process, we have here, to start, we have the roaster. We have the mass going in equals the mass coming out. As you can see, the green beans going in equals to the mass of the chaff plus the gas plus the roasted coffee beans. Then we move on to the grinder. We also have mass going in equals to mass going out, as we show here, 80 grams in equals to 80 grams out. Finally, we have the kettle. As we heat up the water, there will be some water being evaporated during the process. So you can see the cold water coming in equals to the hot water left in the kettle plus water as gas. And finally, we will have the heated water combined with the coffee grounds. And you have the mass of coffee grounds plus the mass of hot water in equals to the wet grounds plus the brewed coffee mass coming out. Okay, then here we're gonna break down the roast profile. We use the beans particularly from the country of Kenya, specifically the Nyeri Ikamama region. And then for our roast profile, you can see the fan setting and the power setting for each of the time window. And the goal is to reduce the fan setting and maintain the power setting as the first crack occurs to get a more evenly roasted profile. Okay, we'll move on to energy usage. Here we're going to look at the roast process energy usage. So for our final project, we had to do 3 roasts, and here we have the mass of the green beans and the mass of roasted beans and the energy to roast. And combined, we get 0.114 kilowatt hour energy use. Here's a brief breakdown of the temperature profile during roasting. As you can see, the temperature rise very quick at the beginning and it slows down towards the end, as you expected. Here we have 2 thermocouple signals. One is touching the bean, one is just air temperature. As it makes sense, the exhaust temp is slightly lower than the actual bean temp. Okay, here is a demonstration of our coffee bean grinding at this grind size of 20. And then here we have a demonstration of our water getting heat up in the kettle. As you can see, it's set at 93 degrees Celsius and its current temperature is at 42. Oh, look, the number's going up. Oh my goodness. And then here, the chart on the left is the energy usage breakdown during water heat up. And when it comes to 1,000 grams of water total, it cost about 0.2645 kilowatt hour of energy. And then finally, we'll move on to brewing. Here's a short demonstration using the Clever Dripper.
So much. So much. Started by Matthew.
As you can see, the TDS was measured to be 1.38%, and then the PE is calculated to be 18.5%. You can find a detailed calculation in the final report. Here's a brief chart to look at the comparison between our actual TDS comparing to the ideal TDS. As it turns out, our TDS is at the ideal level. And then finally, we talk about the sensory evaluation and the potential improvement that we can input. So for the sensory evaluation, our coffee turned out to have a lingering dark sweetness as well as a dark berry fruitiness. Our final results wasn't in the top 3. We think is due to the fact that the beans itself contain a unique taste. So our potential improvement is to pick a coffee bean origin that's different from Kenya and is more suitable for a wider audience taste. And we will remain our brew method to be the same. Thank you guys for your time.